Alright guys, some of you wanted a video for the answer key here to 11.3. Alright, so we'll see how long this takes. I might get through most, can't guarantee through all. I don't want to have like a 20-minute video here up on YouTube. Okay. Find the measure of the central angle given the number of sides. Round to the nearest tenth of a degree if necessary. So remember, this is 360 over sides. Alright, so 360 divided by 12, 30. 360 divided by 16, 22.5 degrees. 360 divided by 40 is 9. Wow, these look familiar. Possibly the ones right off the homework slides. 360 divided by 21, 17.1 to the nearest degree. Okay? Find the given angle measure for the regular hexagon shown. So 360 divided by 6 means each of these are 60. And when this one gets cut down the middle in half, that's going to be a 30 and a 30. So EGD is going to be 60. GHD, that's the other side of this right angle, that's going to be 90. E to G to H, that's this little corner here, that's 30. F to G to D, 60, and then those two 30s, so that's going to be 120. Okay, so hopefully that was probably the easy part. We didn't have too many questions with that. Now we're on to the fun part. Okay? So it's 4 sides, so 360 divided by 4 would mean these are all going to be right angles. This is going to be 90 degrees. Okay, when I draw that down the middle, it's going to be a 45. And these angles are going to be 45. And that makes this angle a 45. So, if you remember your special right triangles, you know that this other side is also 4. Okay? So that would be this one's 4 and this one's 4, so each side would be 8. Alright? That's if you remember your special right triangles. If you didn't, okay, maybe you set up a sine, cosine, tangent type of problem. Alright, we don't need the radius for this one. Okay, we just need this edge. So we'll call that one x. Okay, from here we know this one's 45, so opposite would be x. Adjacent is 4. Tan of 45 is going to equal x over 4. 4 times tan of 45 would equal x. And we're going to get 4, because tangent of 45 is 1. Excuse me. So put that 4 down, that makes our side 8 like we talked about. Okay, now you could use your prior knowledge maybe. You know that squares are just side times side. 8 times 8 is 64. Or we could now go with half times apothem, which they already gave us, 4. ANS. So half times 4 times number of sides, 4, times side length, 8. If we go half times 4 times 4 times 8, okay, we should end up getting 64 square units again. Either way on that one. Alright. 12, 1, 2, 3, 4, 5, 6 is a hexagon. So if I were to draw this in, make that triangle, okay, we're going to have 360 over 6. Each of these is 60 degrees. Okay? And if this radius is 4, this radius is 4. Okay? We could have a little shortcut here, because if this is 4 and this is 4, then these two angles have to be the same. Isosceles triangle, base angles theorem, and that's going to make those angles be 60 as well. But let's pretend you didn't know that. Okay, so we got a 4. This is 60. I draw this down the middle. We're going to have a 30. I want this one, and I also need this one. We need both. Okay? So we could have used our special right triangles. 30, right angle, 90. That leaves 60 there. This is hypotenuse. That's 2x. So that's going to make this one 2, and this one 2 radical 3. If you recognize your special right triangles, that would help you out a lot. Okay? If not, we're going to use our sine, cosine, tangent. Okay, so let's draw another triangle here. Zoom in. We got y, we got x, we got 30, and that side is 4. So from 30, we have opposite over hypotenuse. That's going to be sine. 4 times the sine of 30 would be y. And 4 times the sine of 30 is going to be 2. Okay, x is our adjacent, so that's going to be the cosine one. Cosine of 30 equals x over 4. 4 times cosine of 30 equals x. 4 cosine 30, 3.46. Okay, let's put those back up here. So 3.46 is going to be our apothem, right? That's going to be our apothem coming down the middle there. If this one was 2, then this one was 2, and the whole side was 4, just like we kind of planned on. This is going to be an equilateral triangle, 60, 60, 60, so 4, 4, 4. And now we're ready for our formula. Half times A times N times S. Our apothem was 3.46. Number of sides, 6. Side length, 4. Okay, we're going to type those into the calculator. 41.52 square units. Okay, moving right along. We have a pentagon, 5 sides, so 360 over 5. These angles, the central angles, should be 72. And then when we cut that in half, this one's going to be 36. So I already have the apothem. I just need this side. Okay? So that's going to be a tangent type of problem. Tangent of 36 equals x over 4. Opposite over adjacent. So 4 times tangent of 36 equals x. 2.906, we're going to round that up to 2.91. So if this is 2.91, then that other side is 2.91, and our whole side length, 2.91 times 2, is going to be 5.82. And now we're ready. Half times apothem, 4, times number of sides, 5, times side length, we said was 5.82. So 0.5 times 4 times 5 times 5.82. 58.2 square units. Fun times. Fun times. Okay? Those weren't too bad. Alright? Those are pretty straightforward. You just got to remember your sine, cosine, tangent stuff. Alright? That's going to be your fallback. If you recognize 30, 60, 90, 45, 45, 90, you sure can use those. That'll save you some time. Otherwise, if you just remember the sine, cosine, tangent stuff, that should work every time. Okay? I think between all the other classes, I've done almost all of these problems. I still have one to go. Alright, let's look at 25. We'll walk through 25 here. Now, I'm not going to do it fresh because we're already pushing a 9-minute video with 3 of the longer problems left to go. But here it is. I mean, if you want it, you can go back and just like pause and look at the work, or listen to me talk through it a little slower. If you play it, rewind, play it, rewind. Okay? So we have a circle, and we have a hexagon inside the circle. Alright? So our strategy here is going to be to get area of the circle minus the hexagon. Alright, so I'm going to need the apothem for the hexagon part, and I actually need the radius to do the circle part. So I draw the triangle in. Okay? 360 divided by 6 sides means the central angle is 60. They gave me the side length already, 16. Now when I draw the apothem in, okay, that's going to cut it in half to 8. I need this side. That's my length of the apothem. I actually need the hypotenuse as well. That's going to be the radius. Okay, pay attention here. 30, 90, we'd have a 30, 90, 60, a 30, 60, 90. We could follow our shortcut pattern. Short side would be considered x. Take whatever that is, double it to get the hypotenuse, and take whatever this short side is again, put a radical 3 behind it to get that one. And then you're pretty much done. That'd be all the tough stuff. Okay? Otherwise, if you don't remember those, we have to do our sine, cosine, tangent. From 30 degrees, all right, 8's going to be the opposite, x is the adjacent, so that's going to be a tangent problem. Tangent of 30 equals 8 over x. If x is on the bottom, we need to do our little flip-flop. X goes up, tangent goes down, and our apothem is going to be 13.86. Okay? Hypotenuse, y. That is going to be the hypotenuse. 8 is opposite, that's a sine problem. Sine of 30 equals 8 over y. Flip it, y comes up, sine goes down. 8 divided by sine of 30 is 16. Okay, so now I have all of my pieces that I need. I have my apothem, side length, number of sides. I can do the half ANS. I also have the diagonal one of the radius. That's going to help me with the circle. Okay, so my radius worked out to be 16. Okay, so circle, pi r squared, pi times 16 squared. Get that decimal, 804.25. And then now we're going to subtract out the unshaded hexagon. Half times a times n times s. Half times our apothem times the number of sides times our side length. 665.28. We should have 138.97 square units there. Okay? I believe 26 is the only one I haven't done yet for any class, so we'll do that one live for you here. Alright, so if I were to draw my triangle in, 360 divided by 3 is 120. So we had a 10, a 10, a 120. Okay, now I'm going to draw the apothem in. That's going to cut that into a 60. 60, 30, 90, with this being a 10. So if you want to use your 30, 60, 90 tricks, hypotenuse, that's the 2 times 1. So now I know the short one's half of that, 5. And this is going to be 5 radical 3 times the square root of 3, or 8.66. Okay? Let's pretend you forgot how to do that. Okay, just in case. So here we are. We know that's a 60 because we cut our 120 in half. Okay, we know this one's 10. I have the radius. I'm going to need both of these. I need this for the apothem, and I need this to get the side length. And this is only going to be half of the side length. So going from our 60, opposite, hypotenuse. So sine of 60 equals y over 10. 10 times the sine of 60 equals y. That's going to be 8.66. Weird. That's what we had right there. Okay. Next one, let's get our x. That's going to be the adjacent. So it's a cosine problem. Cosine of 60 equals adjacent over hypotenuse. Multiply the 10 over. And what do you know? 5. Just like we thought. Okay? So, here's our plan of attack. Circle minus triangle. The radius of our circle is 10. So 10 squared times pi, we're going to have 100 pi. Okay? Minus our triangle, half, times apothem, times number of sides, times side length. Okay? Half times our apothem was 5. Number of sides, 3. Side length, be careful, this 8.66 was right here. That is only half. So I have to double that. 8.66 times 2, 17.32. 100 pi. 314.16 minus 0.5 times 5 times 3 times 17.32, 129.9. So 314.16 minus 129.9. We should have an area of 184.26 square units. Okay, there's that one. And we did 28 in one class today. Okay, so our plan of attack for this was area of a sector minus that triangle. Okay, now that triangle is different than this triangle. This triangle is a regular triangle that's inscribed in a circle. Now that's not completely inscribed. That's just the central angle there. So we're going to have to do a different formula. We're going to have to use our half times base times height for the area of that triangle. Alright, the apothem will still serve as the height, but we're just not going to be able to do our half ANS really, because we don't know it's a regular one. It could just be isosceles. It might not all have the same sides. Alright, so this 72-degree arc tells me this central angle is 72, and we already have this side being 16. So when I draw my apothem down the middle, it's going to cut that in half to 8. It also cuts my central angle in half here to 36. Okay, so now we have our triangle set up. Okay, so we're going to have to do sine, cosine, tangent. We don't have any shortcuts for 36. So from 36, 8 is the opposite, x is the adjacent, opposite and adjacent is tangent. Tangent of 36 is going to equal opposite 8 over adjacent x. When you have variables on the bottom, we flip-flop. X goes up, tangent goes down. 11.01. Okay, that's going to serve as our height of the triangle. Next, we need our radius, our y. That's going to be our hypotenuse. So opposite and hypotenuse would be sine. So sine of 36 equals 8 over y. Variable on the bottom, we flip-flop. Okay, we're going to get 13.61 for that radius. Alright, now we're ready to go. This was a sector, a slice of the circle. 72 degrees over 360 times pi r squared. Okay, that would have been this whole thing, that whole slice of the circle. Then I take out the triangle and I'm left with this little sliver, the crust of the pie. Okay, so minus half times base times height. Different because this was not a regular polygon, so I couldn't use the half ANS. That's a little bit of a cheater one. Okay, we can't use our half ANS because this is not a regular triangle. It's not a regular polygon. Okay, so we just use our normal triangle area. Half times the base, 16 times our height was 11.01, and that area is 88.08. We subtract those two, and the area of that little tiny sliver, the crust on the pie, is 28.3. Alright, I realize that was really fast. Okay, if you need to see that again, you know where to find it. Alright, and you can slow it down and look at it as much as you want. Otherwise, you got a video here for notes for today, and you need to get to work. Alright, we'll see you guys on Tuesday.